Okay, so we're going to look at lesson number 3, which is a review of rational and irrational numbers. So I'm going to push through this lesson quite quickly. If you have the fraction 28 over 11, how do you convert that to a decimal? Okay, so do that for me. 28 divided by 11, what do you get on your calculators? First of all, is the answer going to be less than 1 or greater than 1?
Greater than 1.
Why?
Because you're dividing by a smaller one.
Yeah, because the top number is bigger. Actually, the top number is twice as big. So it should be 2 point something. What is it?
2.5, 4 repeating.
Okay.
The 5 and the 4 are repeating, not just the 4.
How would I write that with the repeating?
You put a line of 5 and 4.
Okay. So you already told me this is a repeating decimal, which means does it terminate or not?
No.
No. What does terminate mean?
Stop.
Stops. This does not terminate. Okay, so now the fraction 28 eighths. What is that as a decimal?
3.5.
Does this have a repeating or non-repeating pattern? Non-repeating. And does it terminate?
Yeah.
Yes. Okay. Square root of 2. What does your calculator tell you?
1.41421562.
Okay. Does this have a repeating pattern at this point?
No.
No. Okay. Does this look like it terminates? Okay. What if I told you that the maximum number of decimal places shown on the calculator is 9? Does this look like it terminates?
No.
No. I could figure this out, or I could try to see if my calculator could help me out. If I go square root of 2, if I were to multiply this by 10,000 and then subtract 1,142, after this 562, which is where we ended up, I have 4 more numbers. So did it terminate after the 9 digits? No. And I could do this again. I could multiply this answer by 10,000. And then I could take off the 1356. It's showing that it's getting less and less, but that's more so a problem with the calculator than it is the function itself. It's because the calculator is only going to show you so many decimal places. Probably wasn't the best example to show you, or the best use of the calculator. This decimal is not repeating, and it's not terminating. It's not coming to an end. Okay. These types of numbers that don't terminate and don't repeat, we call them irrational numbers. Okay? So what I'd like you to do right now is, with class example number 1, look at each of these numbers. If it's a fraction, convert it to a decimal. Tell me whether or not the decimal is repeating or non-repeating, whether or not it is terminating or non-terminating. And I'll give you about 3 minutes to do that. Okay, so 1/8.
0.125.
0.125.
Not repeating.
So it's not repeating. And does it terminate?
Yeah.
Yes. Okay, so terminating meaning it comes to an end. 2/11.
0.18.
And the fact that I say 0.18 repeating means that it's a repeating decimal. Does it terminate? No, it's non-terminating. Okay, what about 9/7? This one's tricky.
not repeating.
Actually, it is. I'll show you.
Oh, I
It's,
see.
it kind of sucks.
Oh,
Because it looks like it's non-repeating because this 6 on the end. So if I did the same thing that I did the last time where I multiplied it, I get 28571,428. If I take this 12,000 off, that 6 now became a 5. So it is repeating, it's just a really long repeating pattern. The repeating pattern is actually 1.285714, and then this whole thing is what repeats. Okay? It is a tricky decimal. Questions that I give you we'll talk about how we know that this would be a repeating. So this is repeating, which means it is non-terminating. Okay, with D I have 0.94 repeating. Which part repeats? Just the 4, because the line is only over the 4. So we've already said, when we described it, it's repeating. And does it terminate?
No.
No, so it's non-terminating. Okay, square root of 8 gives me this decimal, 2.828.
4,
And then-
2, 7, 1, 2, 5.
This is, does this non-repeating? And then the last one, the square root of 0.16. Okay, is this repeating or non-repeating? And terminating or non-terminating? Okay. So numbers that terminate or repeat can be converted into fractions. All of those numbers on the previous page that were repeating numbers or terminating numbers could be written as a fraction. Anything that can be written as a fraction is a rational number. That's actually the definition of a rational number, is it's a quotient of 2 integers, is how they state a rational number. So whole numbers are rational numbers because I can take 5 and I can write it as 5 over 1, or 10 over 2, or 15 over 3. I can take that number and write it as a fraction. 9/7 then, that tricky one that we had on the previous page, becomes a rational number because it was already written as a fraction. The decimals that are non-repeating and non-terminating are irrational numbers. So it's 2 categories. Either it's a rational number or it's not, because it's irrational. So what you're going to do with class example number 2 is you're going to identify the numbers as rational or irrational numbers. And it says use a calculator to convert the rational numbers to improper fractions in simplest form. So I will show you how to do that with class example number 1. 1.493. How would we do this without a calculator? How would I write this? First of all, is this a rational number or irrational?
Irrational. No, rational.
Why?
Because it terminates.
Because it terminates. So this is a rational number. How would I write this as a fraction? Place value. What place value is the 3? Thousandths. So this would become 1493 over 1,000. And then I would look to see whether or not I could simplify that fraction. Right now I can't. 1,000 I know I can divide by 2s, by 5s, by 10s, by 100s, 25s. None of those numbers I can divide 1493 by. That is its simplest form. To use your calculator, 1.493 and then you press the math button, and there's an arrow, or the number 1 is a little arrow frac. If I press enter on that, what comes up on my screen is 1.493, and this arrow means to fraction. Press enter, and there's my number as a fraction for me. Okay? So I'm going to give you a couple of moments. I want you to do the next 5 questions. Tell me, are they rational or irrational numbers? And if it is a rational number, write the fraction.
Where's fraction?
Square root of 5. What is the square root of 5?
2.2360677.
So it's going to keep going on and on. Is it repeating?
No,
No.
it's irrational.
It's an irrational number. What about 2.347347347347347?
It's repeating, so it's irrational.
It's repeating, so it's rational.
Oh,
And if you put this into your calculator and do the math frac, what do you get for a fraction?
2, 3, 4, 5 over 999.
Try that again. 2, 3, 4, 5. Okay. Negative square root of 81. Negative 9. Is this rational or irrational? Irrational numbers are non-repeating and non-terminating. Does this terminate?
Yeah.
Yes. So it has to be a rational number. And I can write this as a fraction by putting it over 1. There's my fraction. Square root of 4.41. What does it equal?
2.1.
2.1. Which is what kind of decimal? Rational. It's a terminating number, so that means that it's a rational number. If I convert it to a fraction, what do I get? 21 over 10. Place value, this is in the tenths position. Okay, negative 8.11221112221111, on and on and on.
It's irrational.
Irrational. Why?
Because it doesn't repeat and it doesn't terminate.
Yeah. It's not terminating, that's what the ... tells us. And the repeating, it's not a repeating pattern. Does it have a pattern? Yeah.
They go up.
2 1s, 2 2s, 3 1s, 3 2s, 4, but it's not a repeating. I wouldn't be able to put a line over this and get the pattern to continue. So that makes it an irrational number. Irrational numbers can still go on a number line though. We can look at what their decimal approximations are and we can put them on a number line. So that's what we're going to do with these 5. Square root of 14. If you did that on your calculator, what would be the decimal number that you would get?
3.74165738.
So the square root of 14 on my number line would be somewhere between 3 and 4, closer to 4. That would be, I'm just going to put the letter A there because it's less room. Okay, pi.
3.14.
3.14. So B would be
Closer to the 2 than. No.
Yeah, closer to 3.
closer to the
Yeah.
3, right?
Oh yeah, I did my first one wrong. That's why.
Okay, square root of 80. Before I put this into my calculator, can anyone give me an idea of what that number would have to be close to?
10.
10. Yeah, it has to be between
10?
0 and 10 because it's going to fit on the number line.
Yeah.
Would be closer to 9. Why 9?
Because 9 times 9 is 81.
9 times 9 is 81, and this is 80. So is it going to be more than 9 or less than 9? Less than 9. What is the square root of 80?
8.94.
Okay, so that puts me right about here. as close to the 9 as I can get. How would I read this?
You would do the square root and times it by 2, right?
Right, square root of 15 times 2. Or 2 times the square root of 15. And what do I get?
7.745966692.
Okay? So on my number line, where do I put this?
Like, not right by the 8, but sort of by the 8.
Sort of by the 8. Closer to 8 than to 7.
Yeah.
Okay, and the square root of 0.1.
0.31.
So that would go
Minus 0. But not-
closer to the 0 than to the 1. Okay? So now what I would like you to do is I'd like you to do questions number 2 and 4. And I'll give you about 3 minutes to do that. So let's look at 0.363636 repeating as our using our calculator. The key with this, guys, your calculator does not have a line that you can do a repeating. So the way that you do the repeating pattern is you just type it over and over and over again and put enough in there that the calculator recognizes it's a repeating pattern. That's how I get the 4/11ths. So if I had to do 3.95 in my calculator, I would put a whole bunch of 5s. And then I could go to frac. In which case, what do I get?
178 over 45.
178 over 45?
Yeah.
Okay. So now what I want you to do is I want you to do questions number 9 to 12. And that's it for the lesson.